Okay, we're now going to begin piecewise functions. So the first question is, what is a piecewise function? What are piecewise functions? These are functions that we use pieces of two or more functions to create a more complicated function. So let's first work with two lines. I'm going to graph y equals 1, which is also f of x equals 1, y equals 2, which is also f of x equals 2. So I've plotted these, and of course it's not a function because it fails the vertical line test. And so we know this is just two functions graphed on the same graph. What I'm going to do is to create another function using part of each function or graph. So I come up to this first one, and notice this really means it's a shortcut for saying y equals 1 when x is less than 0, y equals 2 when x is greater than or equal to 0. Remember, you can interchange f of x with y. So f of x equals 1 is less than 0 means I only want a portion of this line, and I want the left one. And I know y equals 1 is a horizontal line. So instead of the whole line, I'm going to start at some point on the line, and it has to be an open circle. And I'm going to go straight left, and I don't need that portion. For y equals 2, another horizontal line, I only want the greater than or equal to 0 portion. This means that the line will go left. Now please look at this arrow. Do you see the arrow matches the arrowhead, and over here the less than matches the arrowhead? We keep telling you this, but some of you turkeys keep forgetting it. So I'm not going to want the whole line, but only a portion of it starting at 0. So now let's look down at this graph. What did I say? This is my line y equals 1. I want to start at 0, and I want to go left. So I don't want this. And what else do we know? We know this is an open circle because I clearly stated that I wasn't putting an equal to on it. Now, what do we want for the other one? It said we want only the right portion starting at 0. And so here's the 0 number, but I don't want the left portion. I only want that portion. And so here is our final graph. This is what we're doing. We're taking two complete graphs of two different functions, and we're erasing part of one and erasing the other half of the other. So we only have the left half of the first one and the right half of the second one. Now that I've whet your appetite, let us look at some notation and how we have to translate these words graphically. Whenever x is less than, you're going to open left and have open circles in your graphs. Now notice if you're a horizontal line, you're going to go this way. If you're an oblique line, you're going to open like this or like this. This is negative slope. This is positive slope. Absolute values will do the same kind of thing. If you're a parabola, you form a parabolic ray, you can use more than exactly half of the parabola, less than half, or more than half. Or maybe it's opening down, you use exactly half, less than half, or more than half. What if you're a square root function? You can start and use the whole square root function, or maybe you're not starting at the beginning, or you can open down. So what do the right portions look like? Well, your rays are all, the arrows are all going to be on the right side when you draw. So I see arrow, arrow, arrow. I'm going to start with an endpoint, and this is going to represent the same thing. Don't worry about memorizing these. We're going to do examples of everything you need. I just need you to see the big picture. What's the difference when we open left and there's an equal to sign? We just close all the endpoints. When we have parabolic rays, square root rays, absolute value rays, oblique rays, And when we open to the right, notice the arrows are all on the right. Ooh, I screwed up here. Ooh, sorry, folks. Let me fix that. And when I open to the right, I can be more than half, less than half, exactly half, or I can be more than half opening down, less than half, exactly half. Okay, I got it fixed. Okay, you couldn't see it, sorry. I had trouble holding the phone and doing that at the same time. And then we have our square roots. Okay, we've got more patterns to discuss. And when we finish these, another example or two. And this is an overview. This is not meant for you to start doing your worksheets. This is just introducing. When we have segments, you'll see double, less than x, less than or equal to x. Notice all the combinations. And this just says that you have a segment. You can have parabolic segments, square root segment, oblique line segments, horizontal segments, semicircle segments, where both ends are open circles, both ends are closed circles. Down here it's closed, then open. Over here it's open, then closed. When x is simply equal to 0, you simply have an ordered pair. It's a function value. It's all by its lonesome self. There's nobody attached to it. Now let's revisit the first problem. When we revisit the first problem, what I encourage you to do is tell me what kind of line it is. Oh, it's horizontal, and it's closed. It's open, and of course less than means left. So the first thing, and I know I don't have my Redmond with me, but the first thing I do is I draw a horizontal segment. That's the best I can. And then I say, oh, I need a left arrow, and it's open on the right. For one on the bottom, what am I going to do? Oh, I see it's horizontal, so I draw a horizontal segment. I put in my right arrow, and then I decide, oh, it's a closed circle. So I now know my graph is going to have these two line segments on it. Since I know, and this is what I've said, since I know y equals 1 is horizontal, and y equals 1 is less than 0, then I know it's a horizontal, I know it opens left, and I even know the endpoint. Now here's what's tricky. It's not 1, 0, it's always x, then y. So the ordered pair is 0, 1, and this ordered pair is 0, 2. So when I look over at this one, it's the same idea, only now I tell myself I have a horizontal ray moving right with endpoint 0, 2. Now, why do I know that? I know that y equals 2 is horizontal. I only want the right half, so now I know it's a ray right. And I know the endpoint is what? Plug in 0 and I get 2. So what am I going to do? I'm going to come down and plot 0, 1 as an open circle. And then I'm going to go straight left. So I plotted 0, 1, and I went left. Second, I do the second function, which is the one underneath. I plot the endpoint, which is a closed 0, 2. And then I'm going to make a horizontal segment straight to the right, which is what I did. So now let's look at one more example where I'm going to draw it as we go. I hope. We'll see. All right, I'm going to do the best I can. So what do I know? Y equals x plus 2 is y equals mx plus b. I know it's an oblique line. 5 minus x is really negative x plus 5. I know it's an oblique line, so I have an oblique ray left because I see the left, an oblique way right. I see this is closed, so my endpoint's closed. This doesn't have an equal to on it, so my endpoint's open. What is my endpoint? 3, plug, chug, 5. So I have 3, 5. What is my endpoint? 5 minus 3 is 2, 3, 2. So on my graph, I've plotted those endpoints. Now I want to graph y equals x plus 2. When I have the bottom being positive, it means I'm moving right. When I have the bottom being negative, it means I'm moving left. And which side is my red one? My red one is the left side. So since my red one is the left side, and I now have my red marker, I'm going to want to use that slope. So I come over here and I'm going to go down 1, left 1. I can go down 1 more, left 1 more, down 1 more, left 1 more. I can keep doing it. Or folks, I could have just come up here and said, gee, the y-intercept is 2, and just plotted these 2 points. But anyway, I'm going to draw it, and my arrow goes down. Now, why did I know that? Well, let's analyze. Y equals x plus 2. M is equal to a positive 1, and so it's going to go uphill. But I told you I wanted to be less than or equal to. So that's the left side. So I put my left arrow on, and I put a closed dot, and that's what I did in my picture. So I knew what it was going to look like before I started. Let's analyze this one. I know y equals 5 minus x is negative x plus 5. The slope is negative 1. That means my line's going to go downhill, but this is the right side. And from up here, I see that I need an open circle. So I always have you draw what the picture should look like, a little sketch, before I start. So let me erase this. So now let's go to do the second half. So the second half, I saw that the slope is negative 1, so that's negative 1 over 1, or 1 over negative 1. Which portion is this one? It's the right one. So I'm going to do the slope this way. And so now I go down 1, left 1, down 1, right 1, down 1, right 1. And so there's my sloppy rendition of what my graph would look like. Notice it matches the sketches I have up here. What you don't know is where does it start. And sometimes the red one's below the green one, and sometimes the green one's below the red one. And believe it or not, as we do some of the problems, sometimes they hook up and it's going to just look like some kind of warped V. And other times we'll see they hook up with a closed circle and they hook up with a open circle, and we'll have some crazy little ordered pair somewhere else floating down there in space. So this is the intro video. I'm now creating videos of each set of problems you need to do that you will watch daily.